Hello, this is Sumanto Day, and welcome to my lessons, SD lessons. Today I am going to show you few things regarding organic chemistry. For that, we need to understand some basic things. Why mainly I am doing this particular chapter? It's all because of the board students. Their exams are going to be held just after 2 or 3 weeks. So, all the best, children, and for you, a quick brushing through this chapter. So, organic chemistry, for all those who feel that this chapter is a little tricky, but there is nothing tricky in it. Let's start. So, first thing what we need to know is carbon. Its mass number is 12. Its atomic number is 6. That means a carbon has 2 electrons in its innermost orbit and 4 electrons in the outermost orbit or valence shell. As a result of this, carbon neither loses nor gains electrons to form bond. Metals, they have 1, 2, or 3 in electrons in the outermost shell, so they lose electrons to form electrovalent bond. Similarly, non-metals have 5, 6, or 7. They receive electrons and they also form electrovalent bond. But in case of carbon, what it does is there it will share this electron with another carbon here with 4 electrons outside, and it forms a bond here which is called covalent bond. Now, if we start drawing in this manner of putting carbons here all around and then we start making these bonds, it will look untidy. So the best way of drawing is representing is we make a carbon and put a dash. This dash means one bond here, or this one bond here. Put a dash here means this bond here. Put a dash means another bond here. Put a dash, another bond here. Now, this is called tetravalency. This characteristic of the carbon atom, by virtue of which it forms 4 covalent bonds, is called tetravalency of carbon. So you can see 1, 2, 3, and 4 bonds. Now, there is a unique nature of carbon, like one carbon can link with another carbon, can link with another carbon, and it can link with another carbon, and this side also, and there will be other bonds with other carbons this way also. Now, if it forms a straight chain like this, it can form a straight chain, or it can form a branch in this way, or it can form a ring in this manner. It can form a ring in this manner. Now, this unique property of self-linking is called catenation. So, what is catenation? Catenation, when carbon, 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 they can link with each other, and it has a unique characteristic of linking. The chain can be merely very long. One thing comes in our mind, whether only carbon can do this or there are some other non-metals which can also do linking, self-linking. We know about silicon, we know about 1 or 2 others also, but their ability of self-linking is not as much as carbons. Carbon can go into a long chain, a branch chain, long branch chain, or ring, several types of ring. So let me go into the next now. Let me change the page. Now, what do we see here? Carbon, carbon sharing of a pair of electrons. One electron here, one electron here. I'm talking about this one. So here you can see sharing of a pair of electrons. That's a single covalent bond, single bond. Then if there is one electron here, one electron here, shared, one electron here and one electron here, So 2 pairs shared, so it is double bond. Then 1 electron here, 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 1 electron here. That means sharing of 3 pairs of electrons or triple bond. So in the first case, if it is in this one first case, a single bond, so you will have 1, 2, 3 here this side. So single bond, so 1, 2 and 3 other bonds. So this will have 2 other bonds, second case in the double bond, and in the triple bond you will have only 1. Next, let me show you what is homologous series. Homologous series. Now if you look at this one, CH4, C and 4H here, and the next one, if I join one more carbon, so what is the difference you see? What is the difference you see is one extra carbon than this one, and 2 extra hydrogen. Here it was in methane, this one is CH4, this one is C2H6. So it has increased by 1 carbon and 2 hydrogen. Let me open another page and explain this. So let's see the homologous series once again. You look at the first one, C and 4H linked with 4H. That's a compound called methane. And if one more carbon increases and 2 more hydrogen increases, I'm not writing the H here, means it, and the next one is 1 more carbon increases and 2 more hydrogen increases, and the next one again 1 carbon increases and 2 hydrogen increases. If you count, you will know this. The first one is CH4, second one is C2H6, third one is C3H8. That means it's increasing by CH2. CH4 plus CH2 plus CH2 gives you this C2H6 plus CH2 will give C3H8, like this. Keeps on increasing by CH2. This CH2 is called methylene group. So it increases by CH2. So this is called homologous series. Just an example, it can happen with alcohols as well. I'm showing with only the alkanes. I'll explain what is alkane, alkene and alkyne next. But then you see it is increasing by CH2 against CH2. So what is happening is the molecular mass is increasing. Say the first one, CH4, it was how much? 1 carbon is 12, 4 hydrogen is 4, 12 plus 4, that means its molecular mass is 16. What about this one, the next one, C2H6? It will be exactly 14 more and its molecular mass will be 30. Why 14 more? Because 1 carbon is 12 atomic mass, 1 hydrogen is 1, 2 hydrogen will be 2. So 16 plus 4 you get 30. What about the next one? Again plus 14. So 30 plus 14, it gives you 44. So the molecular mass 16, then 30, then 44. What is the interesting facts regarding what is the purpose of studying this homologous series is there is a gradation, means gradually as the molecular mass increases, the we see that the boiling point also increases and their physical state, like this one is a gas, this one is a gas, next one is a gas, and as we go higher up we come across liquid. So gradually it changes, so let me open another page. This is too cluttered, not becoming clear, so open another page. Now look at this homologous series of alcohols. These are called alcohols. Why? I will let you know later. Now at the moment you remember there is a group. Here is a group that gives its particular function and name. This is called alcohol or alcohol group. Now what I am telling you at the moment is, you notice that here is one carbon here, carbon has increased to 2, again one carbon to 3, again carbon to 4. So gradually it is increasing by 1C. And if you look at this hydrogen, this is constant, this part is constant, so it's not changing. Look at this, CH3 changes to H5, so plus 2, H7 plus 2, H9 plus 2. So this is also increasing by methylene group, 1 carbon and 2 hydrogen. That means it will increase by a molecular mass of 14. 1 carbon is 12, 2 hydrogen is 2, 12 plus 2, 14. And gradation you don't require now, but then there is a change, gradual change in its properties. So this is what helps in studying homologous series, like we can predict the properties of even those members of the series that are yet to be prepared. And then there is a useful for the systematic study of organic chemistry. So there is a significance of homologous series, you need to know that. And the next I would discuss about is nomenclature. Now nomenclature I am not going to discuss now. In my next post you look for this nomenclature. I will continue with the class. It's a lengthy chapter, so needs to be stopped here. So thank you boys for today. Look for my next post.